Welcome to the second to last presentation of the last day of the SpringOne Platform Conference. So thank you for hanging in. I know it's been a long show. My name is Brian Joe, Senior Director of Product Management today. Some of you may have seen the abstract already, but the core of what I'll be talking about is really just about the value of networking for a developer. So as you think about a lot of the things that have happened in development today, the cloud has made it really easy to build apps because of abstraction. You don't have to worry about things that are below the application layer. But when you lose sight of what's going on in the network, there's actually a lot of value that you leave on the table. And networking does have a lot of value. So what I'm going to be focusing on today is how you can take advantage of some of that value and build better apps. A little bit about me. So I currently work at Signal Sciences, which is an application security company. We protect web apps and microservices. Before that, I was working at Verizon. And I spent most of my career focused on networking and infrastructure products. An interesting thing about me is that I can climb telephone poles and repair phone lines. So if any of you are having trouble with that, you can find me on Twitter. I'm happy to help with that. OK, so just a quick agenda for what's coming in the next few minutes. So first, I'll be talking about networking in the cloud and the relationship between the network and the cloud. Next, I'll be talking about why networks are valuable. And then I'll be closing with how to build better apps using the network. Networking in the cloud. So when you think about networking, well, when you think about the cloud, what you don't really think about is networking. You usually think about things like virtual machines, containers, serverless. But networking is kind of the black sheep of the cloud. And it's a little bit ironic because networking is also the thing that really makes the cloud possible. I've once heard the definition of the cloud as someone else's computer. And the only way that you can use someone else's computer is through a network. So I think it's that fundamental attachment to the cloud that's really made networking a bit of a black sheep. So if you think about all of the hype and all of the cool things that are going on in cloud today, it's all around things like Kubernetes or containers or elasticity, but not so much about networking. Let's talk a little bit about that. So if you think about virtualization in terms of the cloud, what it's done is it's really just made hosts smaller. So back in 2001, if you were listening to the last talk, everyone was using physical machines. And physical machines were great. They're really straightforward. But there was a lot of extra capacity on them, typically, when you put your apps and deploy it in production. So what do you do with that extra capacity and extra resourcing? Well, we came up with the idea of virtual machines so that we can use more of those resources by deploying multiple machines on a single physical machine. Then after that, we realized, hey, we're using all these VMs on physical machines now, but we still have extra resources on these VMs because we're taking in all this overhead for things like virtual storage, virtual memory, virtual I/O. Even multiple copies of operating systems. Let's see if we can virtualize that another layer. And so now there's containers. And even after containers will be serverless, and I'm sure that in the next few years we'll see even more and more abstraction to the point where maybe we'll even abstract the developer. But let's think a little bit about what this change in computing has done to the network. So back in the day, networking was pretty straightforward. You would just plug a cable into the back of your machine. Back in the early days, I remember once I would do this in my own home, set up multiple computers, and I'd have all my friends over, and we'd have these things called LAN parties, where we'd hook our computers together and play games with one another. But this was not too dissimilar than what was actually going on in enterprise IT. Physical machines just connected with physical cables. Each connection that you had was tied to a physical cable. But as virtualization has made hosts smaller and smaller, the number of connections has changed. The number of connections has grown exponentially. And not only is it the number of connections, but the state and ephemerality of those connections has changed as well. So it's no longer a set it and forget it type of network where you can plug it in and leave it for the next year or two. It's actually more dynamic and more elastic than that, where networks might be up, might be down, every time you spin up or create a service or infrastructure API. And if you take that to its logical conclusion, you get a very complicated network mesh. So this diagram, some of you may have seen it before. It's actually fairly old, but it's a diagram of Netflix's microservices architecture. So what you see is basically an uncountable number of endpoints connected by another uncountable number of network connections between them. And so one of the challenges with networking and microservices, really there's three challenges. One is around scheduling. So since not all of these connections are persistent, you need to know when they're available and when they're not available, and when to turn them on and when to turn them off. Second is management, keeping track of all of them and letting different consumers understand when and where to use them. And then troubleshooting. Troubleshooting is a big challenge when you have a problem with the service mesh, because you don't know who's involved and you don't know who to talk to. So in order to address some of these challenges in networking, what we should really do is come up with some kind of network virtualization, right? That should be like the next wave in technology. But the thing is, network virtualization is actually a very old technology. It's been around for over 30 years. So some of you may recognize this diagram as the OSI model, which is sort of this fundamental principle in computer networking that divides a network connection into 7 logical layers. So it's kind of like abstraction and virtualization on the host level or for compute resourcing, except for the network. And so the key thing, innovation of this model when it came out in 1984 was that it introduced this idea of encapsulation, which is analogous to abstraction. And it allowed that different people who worked on different sections of the network could innovate independently. So you might have application developers focused on the top level, and more network engineers focused on sort of the lower levels, maybe even network technicians focused on the bottom levels. So one of the things that was great about that was innovation happened at different layers at different speeds. But what we saw is that innovation really kind of funneled to the top. And most of the innovation was actually happening in the application level. And now what's happened is, with a lot of the emergence of cloud technologies, is most of the functionality of these lower 6 levels of the OSI model have been built into layer 7. Okay, so that was a little bit of a brief overview of how the network is related to the cloud. Now I just want to remind everyone a bit of some of the things that network can do for you and some of the value that sits within the network. So the first and most obvious thing is speed. So I think most of us have dealt with slow web pages or slow applications and been really frustrated. But one of the things about networking is that, and most modern web apps, is that they're not just comprised of your code. So as a developer, when you're building an app like, say, the Teslarati website, you're probably building the front end, the frameworks, maybe some of the back-end management systems. But when an end user is actually going to the site, it's not just your content and your software that's being loaded. It's hundreds of other things. So there might be ad code, there might be ad pixels, there might be third-party media. There's all sorts of things that you might not even be aware of how they work. You just put in a library or a JavaScript from somewhere else, and before you know it, your page is taking 10, 15 seconds to load. So having an awareness of what is on your page or what is in your app and where it's all coming from is actually something that can make a big impact on the actual performance and perception of your application. There's a whole number of technical things you can do to actually try to improve these types of latencies. So one common thing is actually optimizing the images. So adding some intelligence into your application so that you know what kind of device you're serving to, and you're not over-serving a picture or a video that's too big for it. Another idea is lazy loading, where you might load only things above the fold and save the stuff below the fold for later. Caching, minification, compression, all of these are techniques that developers should be using to make their network more, or their application more performant. So another thing the network adds to an application is reliability. So clouds go down all the time. I think here's a few clippings of some rather high-profile cloud outages. And applications that we build, they need to be resilient, and they need to be able to work around these kinds of outages. And the only way that you can do that really is by using the network. If a whole AWS region goes down and all of your stuff is in US West, then you're stuck. Unless you've thought through failure cases and how to take advantage of other regions and interconnect applications in multiple regions to one another. So the network's really key to that. Tools like DNS, load balancing, health checks. These are all sort of key things that you need to consider when you're building your application. When I was at Verizon, I worked on a CDN. So it was a CDN is a content distribution network, which is a very, very distributed system with over 100 different data centers running simultaneously. And so it was really good in the sense that we had a very resilient network. It was 100-to-1 redundancy. But in order to provide that redundancy, it was very complicated. We had to do all sorts of things with DNS. We had to do special routing called Anycast. And we did all of this and make sure, and we made sure that there was a very high SLA so that customers could just come to us with a simple web app and we can make it reliable for them. Another thing the network can do is provide security. So ideally, security is built into the app in the sense that your code has no vulnerabilities and everyone's writing perfect code. Raise your hand if you've done that. That's what I thought. But it's not realistic, right? So I think network-based security or perimeter-based security, it's not recommended as a thing anymore. People talk about zero trust security. The network is sort of changing in the sense that there's no perimeter defined anymore. But in terms of practicality, sometimes it's just easier to build a wall around your application than to actually try to go back and instrument all of the different parts of your application, particularly if you're dealing with older applications or having to maintain apps that somebody built that aren't well documented. It might just be easier to enforce security at the edge or just from the network. Uh-oh, looks like I'm having a computer problem. Okay, all right, so the last part of my talk is really how to build better apps using the network. And this is a little bit more specific. So first thing you can do is just build a simple system. So I define a system as really all of the services and APIs that you're building as developers, but also the network that interconnects them and the design of that network and how all of those services come together. So simplicity in and of itself can sometimes seem boring, or it can seem like it's really old. You don't want to use something that's been done before. But simplicity isn't a bad thing. It's hard sometimes to avoid the temptation to build complexity into your app because you want to use the coolest, newest technologies. You want to use GitHub Actions. You want to use Kubernetes. You want to use all of this new stuff. But then you end up with a system that is so new that it's hard to maintain, and not everyone knows how to maintain it. And there's not a significant knowledge base of people who can support it. Another thing you can do when you're trying to design a simple system is just use common patterns. So there's a lot of advantages to following common patterns. I think the biggest of those is that you have community support. You have other people out there who've built apps, probably scaled apps at a greater capacity than you might need for your app, and have a lot of lessons learned and knowledge on how to actually implement those in a good way. So this diagram is actually lifted straight off the Pivotal support website, and there's a whole bunch of nice supporting documentation around how to implement this 3-tier architecture, which seems kind of boring, but is actually very easy to maintain. So just imagine troubleshooting the Netflix example, right? If something went wrong in the network, what would you do? You wouldn't know. If you're a developer and one of your services is not working, it'd be pretty challenging for you to unpack what's going on. So the other advantage of simplicity is troubleshooting and being able to diagnose where problems are coming from. Not to say anything poorly about microservices. Microservices are a great design pattern, and I think particularly in larger companies, they make a lot of sense so that multiple parties can work within the same code base. But there's a lot of overhead involved with coordinating who's involved in working on what. Okay, so I talked about building a simple system. The next thing you can do to build a better app is actually build with specific goals. So some of you might recognize this car from The Simpsons. This car is called the Homer, and it's an example of a product that was built with no goals. I think in this particular episode, there was a focus group built around Homer Simpson, and they just built whatever he wanted. And the end result was a car that nobody wanted except for him. By having specific goals, this will actually help you prioritize what you want to do and what you want to accomplish, and actually focus on solving real problems rather than just adding more features and technology into your application. The other great thing about building with specific goals is that they will help you figure out a plan to get there. So this meme is from an episode of South Park where there are these gnomes who have a plan to get rich, and their plan involves phase 1, collecting underpants. There's no defined phase 2, and then phase 3 is make a lot of money. And so I find this cartoon pretty funny because even though it seems ridiculous on its face, I oftentimes see many teams kind of taking the same approach when they're building applications. They think, you know what, we're going to use the newest technology, we're going to do blockchain, we're going to do 5G, we're going to do edge, and then we're going to make a lot of money, but there's not any real plan defined or real problem being solved. So you can't be successful if you don't really have a plan. So just a specific example of how you can do that. So what I did here on this table is I showed just some things you can do to enhance your application. So kind of referencing the things that network can do for you. So speed, using techniques like lazy loading or caching, or reliability, security, or just more features. So those are the technologies and improvements you can make to your application. On the left-hand side are actual goals or specific goals that you want. So those goals might be acquire users, retain users or make sure they keep using your app, convert users so that they actually do what you want, whether it's buying something or checking something out, or expanding the way that they're using your app. And so if you try to attack all of these goals at once, or you try to attack all these different technologies at once, you're not really going to make an impact, and you're not going to accomplish anything. So what's really key is knowing what goal you want to achieve at a specific time and focusing on that. So as an example, if you want to focus on acquiring users, probably you want to be optimizing your page load times on Google, or showing up earlier in the search results. So investing in things like AMP, or page load times or speed can actually help a lot with that. And so that's an example of how you can really hone in on what you want to do and how to make your app better using specific goals. Okay, the other thing you can do with a network is build on the edge. So the edge, and edge computing in particular, is getting a lot of hype. This clipping is actually just from 2 days ago. From the CEO of Microsoft. Really, it was from a meeting where he met with, I think it was in Washington, D.C. with government leaders, and he was just really talking about the power of edge computing. And so the edge is getting a lot of hype, but I think there's also a lot of murkiness around what the edge actually means and how it can help. So what is the edge? I did some investigation, and on Wikipedia, the edge is 3 things. So the edge is a Microsoft browser, the edge is a pro wrestler, and the edge is also a guitarist from U2. But I think the edge he's talking about is actually this edge, which is the part of the internet that sits between the cloud and the end user. So if you think about the cloud, you might think of that as a distributed system, but it's actually not. Like AWS, they have 18 regions or so. And if you think about where all of your end users might be, that's a lot. They're in a lot more than 18 places. So the edge is sort of that middle layer in between the cloud and the users that's even more distributed than, say, where your core data centers are, but not all the way at the end users. The advantage of the edge, there's really 2. So the first is that it reduces latency between the user and your workload. So if you have a workload running at the edge, there's going to be less latency between the user and the workload, which is great for performance. And the other benefit, which I think is sometimes overlooked, is that it reduces the computational resourcing that's required at the end user device. So this isn't a big deal if you're talking about laptops or mobile phones even, but if you're talking about embedded systems, say refrigerators or toasters or parking meters, Internet of Things type things, that's where there's not a lot of compute resources available and where the edge can make a lot of sense. So if you think about sensor networks or AR, VR type things, those types of workloads make a lot of sense for the edge. But at the same time, most workloads are not well suited for the edge. So even though the edge is getting a lot of hype, I think this is a great example of where building using the latest and coolest technology isn't always a good idea. So it's fairly challenging to build an application that is edge native or able to be distributed in multiple places. There's a lot of problems to worry about. Load balancing and failover are probably the biggest, as well as other fundamental things that you take for granted, things like logging and monitoring or configuration management and distribution. Those things are all pretty hard at scale when you're talking about multiple data centers. So if you want to build on the edge, you probably just want to start with using caching. Use a CDN, which is a edge-based system, and just cache objects in your application, whether they're pictures or videos, cache them at the edge. And you kind of get some of the benefits of edge without actually having to architect your system for distributed scale. Or if you don't even want to do that, and let's say you do want to build an application that's edge native, maybe it's an AR, VR app, then you might want to work with an edge specialist. Another thing you can do to build, to make your app better using the network is to build observability. And I have a picture of a drawbridge here because observability is something kind of like security. You should be building it into your application as much as possible, but sometimes that's not practical, you don't have time, or you've got a lot of old stuff laying around. So the network is a great place where you can actually get a lot of visibility and observability with very minimal work. So if you think about, say, Kubernetes, most of your traffic is going to flow through that ingress because that's where all of the demarcation between your backend and end users typically is. The network can also be used to monitor traffic between your microservices. So Kubernetes ingress and sort of other container ingresses are great places to get that observability. So once you have that observability or some kind of basic framework in place, you really just want to focus on logs and basic visualizations. Logs to get the details, and visualizations to understand trends. So these are just screenshots from the product that I work on at Signal Sciences that are just examples of how we let our customers look in detail at their logs and try to understand them in an easier way than just looking at a terminal output. And visualizations are really helpful in understanding larger trends and aggregating large amounts of information. So when you're able to just start here, that's pretty much 80% of the battle in terms of observability. Because when something goes wrong, you can go in and find out what's going on. But the remaining 20% is actually not just having logs and graphs, but actually having sending those logs and graphs and any insights that you're learning to the right place at the right time. So things like notifications, integrations with DevOps tool chains. Some of our customers, for example, like to use Slack for their communications. Others like to use Microsoft Teams. Some like to use Jira to create tickets. Some use Pivotal. So one of the things that we've learned is that for monitoring and observability to be effective, you can't change behavior of where your operations and development teams are working. You just have to send the information to where they are so that they understand what's going on. Another side note is that these alerts and notifications need to be smart. You don't want to overwhelm people with too many alerts because they get alert fatigue. So it's really key to have really insightful alerts that are tied to things like thresholds or patterns that you know about or are specified. Okay, so in summary, to build better apps using the network, There's 4 things. So build a simple system. That's the idea of keeping the network simple and keeping your services simple. Building with specific goals, not trying to optimize every part of your system all at once, but actually focusing on specific things first. Building on the edge and minimizing latency and reducing computational resourcing. And then building observability. Okay, that's all I've got. Thanks very much.